In this lesson, we are going to discuss exponential growth and decay. As a reminder, the exponential function equation is y equals a times b to the x. Anytime b is greater than 1, you have exponential growth, and anytime b is between 0 and 1, you have exponential decay. So growth means your numbers will get larger, decay means your numbers will get smaller. So working on this, we will be making equations, and then we will be solving for a couple of answers based on what we know. So the daily cost of patient care has increased 4% per year. In 1995, costs were $986 per day. Write an equation and find the cost in 2014. So let's start with the equation. Y equals a times b to the x. So y equals a is your y-intercept or your starting point. Here, they say 1995. This is the only number we're given, 986. So that has to be our a. 986. All right, now we need to decide our b. We know that costs were increasing 4% per year. But if I just put in 4%, all it's going to do is calculate 986 times 4%. That's not going to give me an increase. That's just going to give me the amount it increased. So to show the increase, we're going to say that 986 was 100%. That was 100% of the cost in 1995. And every year since, we've added 4%. So my ratio here, my b, is going to be 1.04%, or 104%, which we would have to write as a decimal. So if you remember back, a percent can't go into a regular equation. We have to change it instead to a decimal or a fraction. Now that we have our equation, let's work on answering the second part, finding the cost. So from 1995 to 2014, 1995, 2014, if I subtract those, that is 19 years. So I'm going to find 986 times 1.04 to the 19th. And that will give me my second answer, which is 2039.43. So here's my first answer, the equation, and here's the cost in 2014. Typically, you will be writing an equation and then also solving. All right. Your parents deposit $1,500 into an account paying 3.5 interest compounded annually when you were born. How much will be in the account when you turn 18? So in this case, we are working with compound interest. So we need the compound interest equation. And that is amount equals principal times 1 plus the rate divided by number of times it's compounded to the exponent of number of times it's compounded per year times the number of years. So we're just filling in blanks now. A equals, your principal is the $1,500 you started with, or they started with. The rate is this 3.5%, but I need to change it to a decimal, so 0.035. N is how often it's compounded in 1 year, so just once. And then how many total years are we talking about? Would be T. And then when we throw this all in a calculator, you get $2,786.23. Now, what if we did quarterly instead? So all we're changing from that original equation is N. N is now going to be 4 instead of the 1 from up here. So A equals 1,500 times 1 plus 0.035 divided by 4 this time. And then our exponent is 4 times 18 now. So A equals $2,808.71. In general, for savings, you get more money if you compound more frequently. For loans and things, you want to compound less so that you have to pay less. So interest can kind of work both ways. All right, last example here. We have, since 1980, the gallons of whole milk each person drinks has dropped 4.1% per year. In 1980, the average was 16.5 gallons. What was the average in 2010? So now we're back to regular exponential equation. So A times B to the X. Here is our A. That's our starting amount. So 16.5. And now let's find our B, find our ratio. So again, let's term 16.5 as our 100%. And then we know it's dropping 4.1% each year. Well, that's a subtract of 4.1. So if I'm doing 100% minus 4.1%, we end up with 95.9%. Now, we can't put it in as 95.9. We have to change that to a decimal. So 0.959 to the X. And I'm looking from 1980 to 2010. That would be 30 years. So my X will be 30. Ooh, let's erase that X. And we'll update it. From here, this is all straight calculator work now. So Y equals 4.7, and we're talking gallons of milk.